All right. So we're about to go ahead and get started on this phaser tutorial. Again, if you are into game development and want to really start diving into it in like JavaScript, this is a great way to go. We're using this phaser framework. If you already have experience with Unity, is very similar to it. In fact, it has a lot of starting methods that mirror what you get out of Unity when you create their scripts. So I'll be talking through that too. So getting started here, I have this empty folder right now. The first thing I want to do is I want to create an index file. So I'm going to come over here. I'm going to click this new file, just type in index.html. And then using the shorthand, I'm just going to do an exclamation point and hit tab. And I now have my index. It's wonderful. I can see here, there's nothing going on, but we will be coming back to that in just a second. Let's see here. So now come down, this is kind of walking through what's required of us. It does have a zip file that you'll want to download. It has both the individual, files that you will be using and also the art assets that we will be using in our game. Since I've already been working with this tutorial, I'm just going to bring my art assets over here so I don't have to worry about it. But it's quick, easy to download, easy to use. I'm just going to paste my assets into this folder here right now. As you'll see, it shows up in our project assets, and we have a little bomb image. We have a little dude image. This is what's known as a sprite sheet. We'll be talking about that in a little bit. We have a platform, which is just a square block. Sky, which is a gradient. It's just square blocks that are different shades of blue to create a gradient. And then we have a little star. Those are all provided to us. You can use whatever art assets you like. We're going to say phaser. And then I'm also going to go ahead here and I'm going to just grab this. For anyone interested in following along in chat, I'm going to go ahead and put it in chat. And since I'm going to be uploading this online, I will put this here too, so anyone can follow. So the first thing it's doing is it's going to start talking about the JavaScript that we need to have as a part of this. You're going to see a lot of code here, this var config and these preload. These are all integral to our game. Since there's a couple of different ways we can approach this. Let's see now. Let me go ahead and grab the start of our code from the last one. And I'll explain what's happening here. In fact, I'm just going to open it up right here, right now. Open with Notepad, or we can do Visual Studio Code too. So there's only two things we're really adding. First, and this is inside of an index, is this script right here, the Phaser Arcade Physics. This is actually the being used via CDN, Content Delivery Network. So I don't have this phaser framework on my computer. I'm calling it from somewhere stored online. There's positives and negatives to this. We're just going to use this right now. Come back over and I'm going to place it here on my scripts or under my head like I usually do with any of my JavaScript. And then here I have my script, and then I actually have my JavaScript code inside of my JavaScript folder. Right now, I'm not going to worry about this right now. We're going to start building it inside of our index right here. So I'm just going to do script. And anyone who hasn't played around with JavaScript before, inside of my HTML, all I do is use this script tag. It has an opening and closing tag, and I can type any of my JavaScript in here and it should work. I'm going to test this out. I'm just going to type alert, open with live server. This is a little message box that pops up whenever I use an alert function in JavaScript. A function is just like a method. So we see that our JavaScript is working. That's great. Let's go ahead and get started. So inside of here on our phaser stuff, the first thing they have at the very top are these functions. And this variable called config, we'll be typing this out. I'll be explaining what's going on as we do it. The first thing I'm going to do is var config. This is actually, this is kind of creating a dictionary. And if anyone hasn't played around with dictionaries in any language, it's much like an array. except instead of using indexes like 0, 1, 2, 3, 4, you can use what are known as key value pairs. So you give it a string or you give it a word, and then you assign a value. So that way you can access it inside of, you mostly have experience. Perfect. All right. Excellent. So then feel free to call out anything you recognize. If you have any questions or want to make any observations, please don't hesitate. So here we have our dictionary going. This is going to be our config file that we pass into our phaser object. So we're starting with type, and then we have phaser dot auto. So what phaser dot auto does is it's actually telling our game object how to render it, because most of the time it's going to try to do WebGL, which is a format made for a format on browsers that allow us to render graphics and games and everything. Though if that doesn't work, it'll try to default back to Canvas. So you can actually choose Canvas if you wanted to, but auto will make the choice for you. So it's best to stick with this. So our next property is going to be width. This is actually saying the size of our window or canvas if you would like. We're setting it to 800. We're going to do our height by 600. Now we're doing the scene object here. Again, we're doing, it's going to have more key value pairs. And we have 3 items. We have preload. We have create. And we have update. And you'll see how these correlate in just a little bit. So we have all of our config information down. So this should be good to go. So now we're going to come down here, and we're going to do var, and now we're going to create our game, and we're going to do new phaser. So we're creating a new instance of this game. And then we're going to pass in our config file. So it rigs it all up. Let's see if there's a change right now. Nothing so far, that's fine. And just to double check, because I might fat finger some things, I am going to copy and paste this just in case I miss something along the way. Nope, we're still good. That's fine. So now we have these 3 methods down here: function preload, function create, and function update. I believe these are directly tied to our scene here. We've said that we're going to be calling these. These will be executed in our code. These will all have their own purpose. We're just going to copy and paste for now. Again, anyone who hasn't done JavaScript before, function is just like a method. So we have our preload, create, and update. Let's go ahead and move on to the next one. Now we're going to start loading our assets. So here, our assets are different images that we were looking at before that are saved under our asset folder. So let's go ahead and start this. We're going to, before I go too far into it, I like to make sure my stuff is properly rigged up. So I'm going to make sure that I can at least get a sky asset loaded. So I'm going to come over here. I'm going to do sky in our preload, this load image, and save. And I'll explain all of this in just a second. But I know that I want to see the sky up here. So I'm going to do this add image. And this is going to be in our create function. All right, fantastic. So we now have this blue sky gradient appearing. That means all my code is working. So I will walk through these steps and explain what's happening. First is our preload, not too dissimilar from something like initialize component. This is going to be the first method that gets called. This is going to load all of our assets into memory from our assets folder right here. And using phaser, what we do is we use this keyword. Then we're saying we're going to load something. And we're calling these images. And I'm making sure to call out images specifically because one of these will be a spreadsheet. So we do image, and then it takes 2 parameters. The first one is going to be your key. Again, there's this key value pair. We're going to do the word ground. And then we give it the location of the asset. Assets slash platform .png. And let's go ahead and test this out really quickly. So I'm just going to copy and paste. And for anyone who hasn't used code, you can just stay on a line, hit Control C and then Control V. It copies the whole line, then paste it on the next one. It's fantastic, makes you go very quickly. I'm going to Control C and then I'm going to Control V here. I'm going to do ground. We now see this ground asset. It's just a green platform. So that's perfect. That's working. And let's go ahead and speed this up a little bit. I know these both look the same, so I'm just going to copy And then we have star. All I need to do is change star. And then I have bomb. And all I need to do is change this to bomb. And I want to make sure all these are working. So I'm now going to do star. And I'm double checking the stuff the entire time, because the second you don't double check one thing, that's the thing that's going to break and you're going to spend an hour reviewing it. So it's just good to get in a habit to check some of the small stuff. So I see a star, I see a bomb, we're good to go. So we're going to go ahead and delete this right now, because in our code, all it's asking for is the sky. So our preload's looking good so far. Now we're doing this sprite sheet. So much like the previous one, we do this load and we do sprite sheet keyword dude. Then we have our assets / dude.png. So that's all similar. But now this is where things change a bit. We have our sprite sheet, and I'll explain what this is. So in old school video games, or 2D video games, even to this day, we use what are known as sprite sheets. And so what a sprite sheet is it has your picture, an image of your character in a game, but it's not just a single image. You'll have all the animations placed equidistant to one another, equal spacing, and then have their entire animation on the sheet. That's because if we have a character that has, take a look at here, this is Hollow Knight. I love this game. This would be a lot of individual images. But what we can now do here is we bring in this whole sheet. You are absolutely right, Chris. Chris has called out that sprite sheet is misspelled, and that is because I do not have enough caffeine. We will definitely be returning to that. Thank you. Because yeah, that would have broken my code. With the sprite sheet, as what we see here, we can have, instead of loading all these pictures individually, we would have just this one sheet. And then what we can do is we basically reference it as if it was a 2D matrix. And we can say, all right, well, I want my animation to start at index 0, 1, 2, 3, 4, 5, index 5, and I want it to go to index 9, 6, or 8. So then it will just loop through these, and it makes it far more efficient to do our animations, store everything on a single sprite sheet. And Phaser does a beautiful job of this. Whenever you see a 2D game, they're probably using sprite sheets behind the scene. And this is what our sprite sheet looks like. It's a single image, but it has 9 different images on it, and they're all spaced evenly, and they're all different frames of an animation. Chris is the new Hannah. Hannah, my TA, is not here today, but she is wonderful, and she is quick to call me out on all my misspellings, of which there are many. It is a full-time job. So when we're looking at this like a sprite sheet, think about it as in if we had an array and this would start at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8. We'll come back over here to our index. Take a look here. Notice that it's taking frame width and frame height. 2 more properties, frame width. We're going to say 32, and then frame height. It's going to take 48. And this is directly referencing 2 things. One, you can probably guess the height. It's how tall our sheet is right here. So it's going to be 48 is probably going to be to about here. But this 32, it's obviously larger than 32. That's because it's from here to here. The width is 32. And by doing this, we're saying what the width is going to be. When this is how it breaks it up. Almost think about it like it's delimiting this image. So 32, 32, 32, and that's how it breaks it up. So this is how we're importing our sprite sheet. Better. It may just not like it in the first place, but you were right. I did misspell it. Here we go. So we're now importing our sprite sheet. And if we wanted to test this, we bring in dude. Our dude is here. That's perfect. And we'll be controlling which way they're facing in a little bit. So we are now displaying our image. We've already been talking about this. So here, when we added our image, we did 400 by 300, and then we used our keyword sky. Well, the 400 by 300 is the location that you're placing it at, and it actually sets the origin point of your image to be the dead center of the image. So here, when we place something at 400 by 300, it's starting at the center of our sky, and then it's setting it at that center at the 400 by 300 of our canvas. And since our canvas is 800 by 600, it's placing it in the center. That's why whenever I did something else, like if I did dude, it placed it dead smack into the center. They do give you the choice to actually make it so that it's started that the origin point is located in the upper left corner. That's quite common too. It will be your choice when you're developing your game. Here, if I want to move this character around, I'm going to say 500. As we can see, it starts to change the location of the character. That will come into play in just a little bit. So now we're going to come back over where you've now added sky. Now we're going to add star. Go copy and paste, and we'll do star. It's important to note that as we're doing this, that these do get loaded in order. So since sky loaded before star, the sky is behind star. But if I did star first, star would be behind the sky. We can't see it. So this is just stuff to keep in mind. So, and remember to keep this order. You're going to do your preload. This loads first, and then you'll do your create. This is what gets the objects going once the scene has loaded, once everything's been preloaded. Keep in mind, you don't necessarily even have to have these. Like I could probably get rid of create or preload and it would be fine. Again, it will depend on what you're doing. This is a larger conversation that involves game development. We can talk about more in the future. We're going to go on to our next step, this world building. We've already been doing this.add. We're now looking at create right now. This is where we're going to load all of our objects, going to populate our world. So here, inside of our create, we're now referencing platforms. This is a variable that we have declared outside of a function scope. They use var. I tend to use let. Follow the tutorial if you're not comfortable jumping between the two. We'll stick with var for now, but I do have words about var. We're going to do var platforms, plural, because this is going to end up being a group. And then over here, we see this variable platforms equals this dot physics. And this is great. This is how we start attaching the physics engine to our world. This is perfect. Add dot static group. And so this hasn't actually added or changed anything yet. We've just added a static group, and we'll explain this in a second. But now the next thing we want to do is we're going to do this platforms dot create. So we're creating a platform, and this otherwise it's not too dissimilar from this image, except for the fact that we're going to be interacting with it in the future. We're going to create a platform. It's going to be at 400 by 568. So this is our location. It's going to be made of the ground. And if we just did this right here, nothing yet. All right. Let's see here. Let me make sure. I want to make sure that I'm doing this properly. All right, not expected to. That is fine. That is fine. Working with it. Ooh, this is why I always want to double check these things. Like, why is it acting up, right? Because yesterday this was working. And now it's choosing to tool with me. So we're going to do create. Let me make sure I've spelled everything correctly. And then we are going to paste and refresh. Interesting. No problem. What I'm probably going to do here then is go to this one. Just to show you what's supposed to be happening here. And I'll grab the code. When we are doing this create, and as you see, I did it properly, and I don't know why it suddenly decided to yell at me. When we do this create and we do these platforms, what happens is it will generate these platforms around our page, as you see right here. And so this is working a lot like our add image, but because we're adding physics, because we want to have a character that, as you see, is going to be interacting and running around on these platforms, we have to give it a physics. We have to attach it to our physics engine. So that's what's happening here. And now you'll see this word static group. That's because the word static indicates that while we have objects that have physics attached to them, they will not be moving. This is not an object that will be floating around. We're not going to have to, it's not going to be hovering around. It's not going to fall when we jump on it. It's static, it is not dynamic. It will not move. So we're just grouping them all together. And then because we are going to be doing all of this stuff here in the future, because this is all basically working the same way, we're grouping it all together as you see here. And so these three are self-explanatory. We're creating the platforms we're placing around here. You'll see if I were to change this to 150, it moves the platform. So much like in our image, the difference here on this one is actually the ground, because we're using this platform image that's a single size. So what we're doing here is we're setting the scale to 2. So we're making it this big, and then we're refreshing body. If we didn't refresh the body, it wouldn't actually update. It's actually staying like the image itself is set to 2 right now. It looks like it's set to 2, but the physics still only happens at the original scale of the platform. So that's why we need to do this refresh body. So it makes it so that the physics is the same size as the image. So this is how we are adding our platforms. And again, this is a platform right now, but in the future, you'll be able to do anything you want where you're adding physics. In the future, I'll be doing an Angry Birds tutorial, and it's the difference between a platform and a column that's moving is just one's taller, the other's wider, and one has a bit of movement. We'll be talking movement in a bit. But logistically, they're not too dissimilar from one another. So here we're now coming down and we're starting to look at our code, and they're saying, hey, so what's going on here? Like, oh, in fact, yes, I think this is the part we need to get to, and this is perfect. Let's try this. Let's go and we're going to go ahead and take this. And now we're going to jump back over to this tutorial. In fact, I'm going to open it up separate. And then we are going to add physics. And let's see if this has updated it. There we go. We now have our platforms. So this is interesting that they chose to do it like this, because if you have something that's taking physics, but you have not imported their physics engine yet, the items will not show up. So that's an issue you might run into. I'm glad you were here to see that. I'm more than happy to be the fool that forgot about that, because I am your fool. So what just happened here, because we added physics to all of this, is we also need to come into our config file and add the physics system and say, hey, this is what we're using. So we used our physics keyword and we populated another object full of key value pairs. The first one is default. It uses arcade. You'll see here in our imported CDN, it's Phaser arcade physics. Physics can have lots of different effects depending on what you're doing, more realistic, more arcadey. Depends on how you want your game to feel. They have multiple options just available to start off with, and people have made their own. Look into it and decide what you want to do with them. We have our physics, we have arcade, and this is where it's actually tweaking the arcade property. And so we can set how much physics we want. As we see here, Y has a physics of 300, which means this is going to be a force pulling down of our character when we put it in by 300. And we have a debug option. In fact, I'm curious. Let's do it on this other one, because curiosity always gets to me. The other tutorial here, we see X equals, we're going to do X equals 500, save it, load this, and just want to see what happens. Notice how everything got pulled over to the side. That's because I just added a physics to X to the horizontal value. So if I did 10,000, there we go. A simple tweak like that, you're able to play around with the physics of your game. Right now, this is just pulling straight down. This might be an arbitrary value. I don't know if they necessarily mean for 300 to equal Earth's gravity. Play around with it as you like. So now we're coming back here to our tutorial that we're following along with. We now see our platforms. So these platforms here, they basically break down what we were just talking about, what exactly is happening in the code. So we'll move on from there. All right, this is where it gets fun. It seems a little confusing, but I'll be happy to walk you through it. It's not nearly as complex as it first appears. So, and you'll see me doing this where I'm adding comments to the end of all my functions. Anyone here who has ever misplaced a curly brace knows the pain. I add I add comments at the end of all my function curly braces, so that way I know where things fall, and just in case I lose anything. These have saved me in midterms. Let them save you in midterms too. So we have all of our platform code. I'm going to also comment platform code. And now we're going to add player code. So the first thing they're having us do is we'll see this keyword player here. Much like platforms, we're going to do var player. This is going to be the main player we're interacting with. And so I'm going to say player this. He's another object that's going to be interacting with the world. So we're attaching him to the physics engine. We're adding, this time he's not an image, he's a sprite. So we're adding a sprite. There we go. And then his starting location is going to be at 100 and 450. This is just a location they gave us. We'll check it out here in a second. Dude. Let's see now. Show up. There he is. Perfect. Made a guest appearance for us. Refresh. Because we added physics, again, he is falling through the world. That's good. It means things are attached. Now we're going to start to tweak these physics values. So things they have here are player.setBounce. We're going to set this. They give us 0.2. Let's see what happens when we look at it. Nothing happens. All right, keeps falling through. This seems weird. Well, that's because we're still not telling him he's a part of the world. He should be interacting with it. He should not go outside the bounds. So we're doing player.set collide world bounds. And we're saying this to true. Takes Boolean true false. And then there we go. That's perfect. He is now, he may not be interacting with platforms, but he is interacting with the outer bounds of our canvas. And just to show here what's going on when we set bounds, notice that when he fell, he did that tiny little bounce once he hits the ground, right? That's his bounciness. Well, now let's go ahead and change that. Instead of 0.2, let's do 222. Now it's extremely bouncy. As soon as he hits something, every time he hits an object, he's going to impart that 222 force. So you kind of see he's yeeting through space and time right now. That's a different game. That's not my game right now, but it's good to know for the future, because if you want something with more bounciness to it, this is something you'll be playing with. That could be fun. And you can be tweaking these values mid-game too. These are all variables. They could get a power up where all of a sudden they're far more bouncy. Just have this variable change to set the bounciness to something else. Keep that in mind. I'm going to set it back to 0.2. Now, this is where we get to some of this funky stuff right here. We'll walk through it step by step. And keep in mind, we're still inside of Create right now. Here we're doing player animation. And this is where that sprite sheet is really coming into play. And let's talk this through. So we do this keyword, and then we do anims. I believe this is a keyword associated with phaser. So keep that in mind. This anims dot create. So we are creating an animation. We're attaching an animation to our character. So we have our key value pairings again. Key left. So we're associating, whenever we call left, we're going to want to call this animation. And then we have this keyword frames. And if anyone doesn't know, frames are basically individual images, still images that you cycle through really quickly to give the impression of motion. You see this all the time. If you've watched a movie in the movie theater, that runs at 24 frames a second. That's 24 still images that they're cycling through to give the impression of motion. Most video games do the same. They run from 30 to 60 frames a second, sometimes a lot higher depending on your computer. Now, when you have animation, your animation is based on different movements between those frames. If we come back to our dude's sprite sheet, this over here on this side, these first 4 images are what are known as a walk cycle. That is, you have a single pose, then you have a passing pose, single pose, passing, run, passing, run. And so what happens is cycling through these different poses gives the impression that our character is walking. And so what's happening here is that we're on our frames, we're calling this anims, generate frame numbers. And we're doing this with dude. We're calling this dude object. And now we're doing this start. We do curly braces as our second parameter, and we have a start and end. And on left, what this means is that it starts at 0, ends at 3. And if we look at our dude image, remember, this is like an array. Start at 0, 0, 1, 2, 3. This is actually going to be looping through 0, 1, 2, 3. And what happens afterwards, you won't let me go back, will you? Won't let me shrink down, will you? Here we go. So 0, 1, 2, 3, and it will keep looping through. And in fact, if we bring up, this is the original, I'll even show you what that looks like right now. We see our character has a run cycle. It's just running around, jumping in between those images, but gives the impression of movement, lets us know what's happening. Are they running? Are they walking? This has a lot more artistic implications, but right now just know that this is what our frame numbers are doing. In fact, you'll see we also have things here like frame rate. We can control how quickly it cycles through those images. So to show you here, on this frame rate, I have it at 10. If I were to set it to 100, we can now see that when I go left, my character looks like they're booking it, right? They're just a hyperspeed right now. This guy's got things to go, places to be. That actually sends a different message than in this casual walk here on the right. But that's what the frame rate controls, how quickly we're cycling through those individual frames. Repeat controls, I believe, where it repeats from in the cycle, though I don't know for sure, so I'm not going to speak anymore on it. Anyway, coming back to our original, we have this will create that walk cycle for the initial for running left. We also have to do it for right. So we're going to go ahead and we're going to take this. We're going to paste. We're going to change our keyword here to right. And use this in relation to anything that you're doing, right? So like if you have an attack animation, a jump animation, make sure your keywords are related to that. Because when you're developing a game, you may have hundreds, if not thousands of enemies, and they're all going to have their animation. So you want to make sure to be as accurate as possible. So here we're doing right, dude, that's fine. But this time, this was for running from 0, 1, 2, 3, 4. This was only for the left. So if this is 0, 1, 2, 3, 4, we're going to do 5, 6, 7, 8. I'm going to have it start at 5, go to 8. And let's see if that's accurate. If we take a look down here, that's right. They start us at 5, end at 8. That's perfect. So that'll be for our right run cycle. Now we have this middle one right here, this turn. So I'm going to grab this. Let's go paste it here. Again, it works almost exactly the same. It's just a little less information. Here, we don't have this animations generate frame numbers. We only have one frame. And that's because that one frame is our character just standing still. Once our character has decided to stop moving, you see he's standing looking straight forward. That's the animation it goes to. It doesn't do it automatically. We have to program it. You'll see us program it here in a second. But run left, run right, stop. That's our default. And so that's what this turn is. It's just playing this frame 4. It honestly doesn't matter if you do 20 frame rate, I believe, because it's just a single frame. So here we're going to go ahead, keep going. This is where they break down basically what we've just been talking about. If you want some more information, please go through this tutorial. It's a wonderful tutorial to walk through. So here we are now going to go ahead. We're going to play around with getting our character to interact with this world. So far, so good. Everything is looking fine, except for one key problem. As you may have noticed, they are falling through this platform. That is no bueno. We don't like that. We want them to be able to jump on these platforms. Hard to have a platformer without that. So now what we have to do is we're going to come over here. We're going to do a couple of things. We're going to come down here and we are going to implement this. This dot physics dot add. So notice this recurring pattern here, this physics add. This is how we add physics to anything. Dot, and this is going to be a collider. Now in Unity, and as I believe the same here, is that a collider is an object that actually says when two objects with physics interact with one another, and that imparts information. In Unity, when you have two objects interact, one sends up a signal that says, hey, these two objects have interacted, but will also give information like how fast, at what location, rotation, all this information. But for this, it's just saying, are these two things touching one another? What do you want to do with it? So here it takes two parameters. We're saying, hey, these two things will collide with one another. The first is going to be our player object. And the next is going to be that platforms object. And again, this comes back to why you want to have groups. Because imagine if I had 1,000 platforms, I would have had to have done this 1,000 times to add player collide with that platform. Whereas here, all I have to do is add the one group and we're good to go. So we're going to do this physics add collider, player platforms. If it works properly, boom. Our player is now resting on that platform. They are now colliding with it, and that collision is saying these two cannot intersect with one another. They're not doing damage or anything. We can code that later, but right now it's just they are resting on one another, and that's perfect. And this is all you have to do. Player interacts with platform. Excellent. And so now we're moving on to our next part of the tutorial. This is where we're going to control the player with the keyboard. This is our interactivity. This is great. So what we're going to do is we see there's a new keyword here, cursors. And this is built in the phaser. This gets the buttons that are being pressed by the user. I'm going to do var cursors. And now down here, they have inside of our create, we actually have to connect this up. Unity is a little different. This is already running in the background, but because we're doing this in JavaScript and with Phaser, we have to rig all this up here. This isn't really a big problem. We're going to do cursors equals, and then this dot input from our keyboard. And without even me looking into it, the fact that they have keyboard here indicates to me that someplace they're probably also going to have a way for you to remap buttons or use game pads and things like that. There are even JavaScript libraries that let you develop in VR, which is something I'm going to be looking into. So this is just one of the things that comes to mind when I'm coding. Someone wrote this for a reason. If it was ever only going to be keyboard, they could have just did input, but they wrote keyboard for a reason, which means there's more out there. So always keep that in mind. We're going to do create cursor keys. This is, again, their built-in method. And now we have to come down to our update loop. So all this time, what you've basically seen here, this is all done once. It preloads once. Everything gets loaded up in the memory. We're good to go. Fantastic. Create. It creates everything on screen. That's fine. It rigs it all up. That's perfect. But when you have a video game, those frames per second, they're actually every frame it's listening for you to do something. If you're big into games, you may have heard of frame perfect inputs. Basically, when you press a button, be it on your keyboard, be it on your game controller, during that frame, it's listening to what the button was, and then it's seeing, oh, how do I respond to this button input? And so because these are static, we couldn't just listen for key presses because then it wouldn't respond. But down here, this update is constantly running. It doesn't just run once, it runs once a frame. And to show off what's happening here, what I'm going to do inside of our update, I'm not putting anything else, but I will do console.log, and I'm going to say this works. And I'm going to save. Now we come back here, we don't see anything happening, but I'm going to right click, inspect, and go to my console. And we now see this works is being logged into our console over and over again. This is how quickly this update is being called over and over again. If we really want to be inclined, I'm going to do count equals 0, count plus plus. Just keeps running over and over again, which is great for us because as a game developer, this is how we're going to be listening for inputs. So let's go ahead and get started here. And I'm even going to test this out. And this is what I do whenever I'm learning any new skill. I want to learn the basics. I want to know what's going on behind the scenes. I don't want to just be like, oh, this just works. This just works is one of the scariest phrases I could say because it means I don't truly understand it. And when it breaks, I am going to be huddled in a corner crying. And that is not fun for anyone except those laughing at me. So let's go ahead and take a look at this. We need to check to see if keys are down. So we're going to start with this if statement because you always have to, again, these are all conditions. These are going back to the fundamentals of programming. This is all variables. These are all, while their methods are all variables and strings and numbers and code someone else wrote, but it all works together to get our result. So now we have our condition and we're saying if, we're calling our cursors object, and now we're saying left. And left here is an abstract term. Does this mean A? Does this mean the left arrow? What exactly does this mean? I'm sure there's some place where we can actually re-rig this. Right now, this is referring to the left arrow. We're doing cursors.left, and now I need to check is down. This should return true or false. In fact, we can do it like this if we really want to. Console.log cursors.left.is down. Run. False, 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 false. I'm holding down the left button. Let up on the left button, holding down the left button. I now know this is specifically returning true or false depending on if I'm holding down the left button. This is a lot of information to use. I love it. So now we're going to come back here. I know what this is doing. I'm going to grab this. Let's test this out. If this is true, you're holding down the left button. So here, not seeing anything, that's good because we don't have a console running without conditions surrounding it. So here now I'm going to press left and our message pops up. Perfect. So our left is down is working. Notice though that when I hold this down, it keeps going. It doesn't stop. This is important to know because it's checking each frame and every time it's true, it'll keep running. Let's say you tied this to jumping. This is important to note because if you had a character that jumped and they kept jumping as long as you held the button down, they're going to yeet off into space, technical terms. So you want to check, you have to check your conditions. Did they press it? Are they holding it down? Did they just press it once? Are they standing on the ground? That's one we'll be talking about in a second. These are all conditions to think about when you're building your game. So here we know this is working for left. I'm now going to come and I'm going to take this. I'm going to do else if we have a left, we probably have a right. And let's have this out. See how quickly it works once you know it, once you're testing, and then how quickly you can copy and paste stuff. Holding down left, holding down right, holding down left. I can't hold down both, which is fine. We know these are working. That's great. Now here we have an else. Would anyone like to take a guess at what the else is going to be controlling? What state, if it's Left moves me left, right moves me right. When might else pop up? Exactly. When we are standing still, when we are not moving left or right, we are standing still. That's what we want to happen. I'm standing still. I'm moving left. I am moving right. And notice, even in that little fraction of a second, I'm transitioning back to standing still because the frames are faster than me switching. Perfect. So this is good. We got our console log written out. And yes, I will very much do this stuff before I start attaching all my animations and the complexity just to know what's going on. So here, this is good so far. Now we're going to start adding some movement. We're going to take our player object. What's happening when we hit left? Player moves left. Well, we know we want them to move to the left. So what we're going to do is they are going to use our function called set velocity. So velocity is how fast something is currently moving. And then we're setting it on X. So like the XY values, X is horizontal. So we're going to say X. And then here it tells us to do -60. And that's because if we take a look at the, yeah, we're getting to you. There we go. So if X is left and right, it is positive when they're moving to the right and it is negative when they're moving to the left. So we want to set our velocity to a negative value to indicate they're going to the left. So that's what's happening here with our code. So perfect. Perfect. Characters moving. Now, can anyone explain to me kind of the weirdness that's happening here? There's a couple different things going on. Let's see about your game logic. What do you think's happening? I'm pressing the left button. I press it once. Needs to end loop, right? It's setting our velocity to -160, but the problem is that it's never being reset back to 0. It does need to end, otherwise it keeps going, and so it's going to hit this wall, boom, and then that bounce is actually affecting it, and so that bounce is pushing it back. So that is absolutely correct. So what we're going to do is come down to our else, because we know our else is standing still. Without even looking, I'm going to take a wild guess. Can anyone tell me how I get him to stop, to stand still? What do I put here? Not even a reset, just 0. If I'm not holding down the button, the velocity is set to 0. Simple as that. Nothing so complex. Good answer, though. If depending on the complexity of my game and what I was having going on, I would absolutely build like a reset function or method depending on everything that needs to come to a rest. In fact, if I was to be so bold, I could probably do and then just call rest. And that would work because well, obviously it'll work because of the code, but I might like this because it's really easy to read now, right? I know, okay, they're not moving because I called this method, keeps everything bound together. That's just a decision you might want to make in the future. But we're going to go ahead and place this back here for now, keep up with the tutorial. So far, so good. So now we have our left, we have our stop. So if I'm going to do my right, so if this is at -160, probably +160. There we go. We are getting the result we wanted. That's perfect. I mean, don't get me wrong, it still looks a little funky, but our character is at least moving left and right. And again, this is something I want to call out. And this is because game development is very much an art too. There's going to be lots of moments you need to keep in mind that you're building little chunk by little chunk. So you have to add all these small components that equal up to Elden Rings or Street Fighter or another amazing game, right? So we've got our gameplay logic going, but now we need to tie in our animation. That's going to be the thing that that's going to be everything we rigged up here. But what's more important almost is that the animation tells us what's happening with our character. If I saw this in a game, I was like, are they backing away from something? Are they at low gravity? What's going on here? So these are important questions to ask when you're developing a game. So now we're going to come over, continue on, and let's take a look here. These are actually fairly simple to call. We're going to come back over to our player moves left. And now inside of here, we're calling this player dot anims. Anims, this keyword matches up with this word here, dot play. And now we're referencing that keyword that we were talking about, right? Left. So we're going to say play left. And now we have true. I don't know offhand exactly what this true is for. My guess is that it loops. I will look that up in the future and make sure to tell you all. But here, let's just test out this one. If it's working, our character now has a walk cycle. And that's brilliant. So that works. So I'm going to copy this. And for right, all I'm going to change is right. Beautiful. And now it looks like he's turning around, right? Well, take a look at this. Still running, correct? That's probably what this true is. It's just looping. It's just looping until we tell it to stop. It looks like he's turning around. In all honesty, all we're doing is the same set velocity, but we are now communicating information with our animation because our dude, when we're running to the left, we have this animation playing. When we're running to the right, this animation is playing. But notice that when my hands are off the keyboard, he's just running in place. That's weird. So what we're going to do is we're going to now come down to our standing still. And let's do this. Player moves right. Player standing still. And now I'm just going to, we have this turn. And I'm going to get rid of this just because I believe I know what it's going to do. Perfect. Runs to the left, runs to the right. As soon as I take my hand off the keyboard, this else plays. They stop and they turn to face towards the camera. This is already feeling pretty dynamic right here. I'm already really liking this. And then let's see, did we match up with them? They still have it. Let's see now. Nope, they don't have that true. So again, I would look this up to be sure, but it's indicating to me that it's probably not running at an infinite loop. So that's fine. So now it looks like we have another if here, and we need to find out what this if is doing. So let's take a look. Come on down. We're going to do if cursors is up. So the up button is down. If so, we are pressing it down. Let's just stick with this for now. Let's just see what happens. We're going to set player dot velocity y, so up and down, to negative 330. So whereas negative 160 had us moving left and right with x, negative 330, let's see what happens. I'm going to come back over. I'm going to press up. Well, it looks like our little guy is flying. This is working out pretty well so far, but I don't want him to fly. Why is he flying? Can anyone tell me why he's flying around? I'm holding down up and he does not come back down. Can anyone tell me why that is? That's absolutely right. She'll only be allowed to jump one time. We're programming all this logic here. As we were talking about before, when we had, this is like, it's just checking to see if I'm pressing it down. It's not stopping. So as long as I'm pressing this up, this velocity continues to be set at negative 330. So it's almost as if I was setting the gravity to negative 330, right? And so that's why they float up. But that's not good. I only want them to jump once. Well, if we take a look back here at this code, this is important. I love this because this is something I usually have to program in Unity, player body touching down. And so what this means, first it's an and. So again, with our if statements and our logical operators, multiple things have to be true. So both of these statements have to be true. It can't just be one or the other. We're doing player body. So it's the object, the player object. Is it touching? Is it interacting with something? And then it's saying down. All of this just means, is this player basically standing on the ground? Are they currently touching the ground from like the bottom of the body? And for us, this indicates, are they standing on the ground? So we're going to hit save. Continue to hold up. They are not flying because they are not on the ground. So while this cursor up is down might be true, the player body is touching the ground is false. So here the player body is touching the ground, yes, but the cursor, I'm not pressing up. So it takes both of these to be true to jump, but that's it. That's perfect. We just implemented our jumping. If we wanted to do something like a double jump, does anyone have an idea of what we might have to do for that? See if I can do it offhand. Not a kind of not really a loop. It's more like let jump twice equals true. So like here, so let's say we have our code right here, and if player body is touching down, let's see now. I'm not going to go all into it here. I'll explain it because I would have to check for more ifs. But basically what we could do is we create another Boolean. And what we say, we have our jump, right? But then what we do is when we press jump again, it will now check to see this Boolean, which will be ready for another jump. If they are ready to jump again, then it will jump again. But it now sets that Boolean to false. And that Boolean will not reset back to true until they hit the ground. And so I would need to check to make sure they've hit the ground in order to set that back to true. It's not that complicated, but I know it's going to be one of those things where I spend too much time just because I need to remember it. But that's just it. You have a Boolean that checks to see if you've double jumped. If you haven't jumped again, allow you to jump again, set this Boolean to false, and then only set that back to true once it hits the ground. That can be a double jump. Can do the same for a triple jump to track all that stuff. It's just checking to see, hey, can I do this again? So let's see here. So far, so good. We have our platformer. We are running around. I'm really happy with this so far. And if you take a note for everything we've written, a lot of this code does make sense. I also say this coming from a Unity background. If you played with Unity at all, this is very similar to already what you do. And if you haven't played with Unity, which is a game engine that uses C#, it would actually be easy to get into Unity from here because they use a lot of the same logic. So that's nice. But here, this is reading very much like English. Outside of this, we are just loading our images. We are just adding things. Hey, I want this to be platforms. I want to add physics. I want to add animation. Here, am I pressing left? Am I pressing right? A lot of this stuff can be pseudo coded out. You can just talk it out and be like, I want this to happen with that, and then write it out and it'll come together rather smoothly. That's not to say game development is easy. It is a large, amazing conversation, but it's not nearly as intimidating to get into as one might believe. Have fun. Because again, I brought up that Vampire Survivors game. One person made that game, I think a couple of years ago. It just blew up recently. That person's making money at $3 a pop, and web pages are talking about it. And he developed it using Phaser. So use this as a jumping off point if you want to get into game development. Side note: the art assets they use in Vampire Survivors. I believe these are all from old school Castlevania games. Like, I don't believe he made that art at all. So he just got open source. Make sure it's open source. Make sure you don't have to pay for it because that's a lawsuit waiting to happen. But he just got all this stuff. And so you don't have to learn art. Find ways to not have to learn a new skill set unless you want to. Stardust. All right, next part of the tutorial 8. It's time for us to now add stars. Let's see what we are going to do here. We're coming back to our create function. We're going to do here. Let's keep this going. Input cursors. And then add stars. So same thing as before, we notice this stars keyword means that I'm probably going to declare a variable stars up here. Again, plural because they're going to be multiple. Notice the only thing that's not plural is player. We want this to be as easily read as possible. So if someone else were to come in and they saw the word cursors, our stars are platforms, they would probably think it's plural. It's a group of something. Player, there's only one. That's important to keep in mind. So stars. We're going to come over here. Stars equals this dot physics. Same thing. Add group, not a static group. Before we did group, static group because our platforms weren't moving. This time our stars will be moving. So we're just doing group. We're still grouping them together, but they will be more dynamic than that. And so we're going to do this as a property. Again, this is stuff you'll just develop over time. Even I don't know offhand when I would use this necessarily. I'm just seeing this because of their tutorial. But as you get practice, you learn the vocabulary, how to pass in objects, when to do this. It just becomes comfortable over time. We're going to do key. We're calling star. Let's see now. I want to make sure that it should be referencing the star up here. And then we're going to repeat. This is going to happen 11 times. And then set x, y. And we're going to do x, 12, y, 0, step x, 70. Here. All right, let's see if anything's happened so far. Look at that. We got our stars dropping. That's looking good. And if we just take a look at what's happening, we see repeat 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's good. And set x, y. They're all starting on the, like when we're saying the x, y, notice that y is starting at 0. So it's starting at the top. X is starting at 12, but step 70. So 12 probably is just indicating this is where it wants to start. This star is probably 24 pixels wide. So when it says start at 12, remember that our images are centered. The origin is centered. So that's why it starts on the very edge. And then the step 70 is when they want this next one of this repeating 11 to appear. So 70, 70, 70, good to go. And the physics are the thing that are dragging them down. The physics is directly referencing this gravity of y of 300. So come back up here. This is looking good so far. We're now going to come back and we're going to see stars, children. So children of these stars iterate. So we're going to go through them each one. And now we're going to do an anonymous function. This is it's not a JavaScript specific thing, but JavaScript loves their anonymous functions. We're not going to get into it here. Just know we are creating a function inside of this. So then we are going to pass it a child object. So stars, children iterate. And I'm going to grab this just to be extra sure. This is a sentence. These are words that I'm more inclined to screw up than anything else. So there we go. Child, referring to this child that we're passing in, dot set bounce y, phasor dot math dot float between 0.4, 0.8. Let's see what happens. Nothing. That's fine. We're going to keep moving because this happened to me on the other one too. So we need to make sure this is why. So The reason that it's falling through is because while all these have physics, we didn't do what we did up here, which was say, hey, these are going to interact with different objects. These need to interact with this platform. So I'm going to come down here. I'm going to do this physics.add.collider, and I'm going to say stars, and I'm going to say platforms. And the thing is, I just saw this part. I didn't read this part yet. We just start to get a sense of what they're asking for, right? People wrote this. They're not going to try to trick you. So you just get used to this pattern. And so now we're saying here, when the stars interact with the platform, start doing some of this stuff. And what is some of this stuff? Here, this is going to be called on every single child. So when we do an iterate, we've done iteration before. Every time we've done a loop, we've done an iteration. Every time it goes through each individual item, it's iterating. So what this is doing is it's basically going through the children. So every single one of these 11 stars is a child of this star object. So we're going through, and this is the equivalent of a for each. And so it's iterating through one by one. And so now this function child, what it's saying is the one it's looking at. So the first star, the second star, the third star. And then we're setting the bounce Y. And we recognize our bounce from here, from our player code. Bounce Y means it's only going to be on the up and down. It's not going to affect X at all. And then this scary bit. Can anyone tell me what this scary bit is right here? Phasor.math float between 4 and then actually this is supposed to be 8. What is this doing in relation to all of this? Any guesses? Not quite. These stars are actually placed evenly across the screen, but in fact, the first time that's what I thought it was doing too. They're not. It's not based on the placement. The placement is based off of this, where we're repeating 11 times and we're stepping 70, so it's going over. What this is doing, and there is randomness involved. This float between this is the min and max. And so it's going through each one of these. The first time it goes through this one, then this one, then this one. And then it's setting the bounce of Y and then using Phazor's math library. You'll find a lot of your frameworks have their own implemented math libraries, just because you're going to be doing specific math that's more important for one thing than another. So while your random may work well for C# or Java, like Phasor is a game development library or framework, so it's going to be more important that it works with floats on certain things. So that's why we're using their math library. And then it's choosing a number between 0.4 and 0.8. So if we refresh, you notice that these are all bouncing kind of at different heights. And that's what this is doing. So we'll even see it here. If I set this back to 4, they all bounce at the same height. But if I do 8, it's looping through and randomly setting it between 4 and 8. And that gives it a bit more personality, makes it a little bit more fun, things like that. Again, those game dev conversations. So far, so good. We have all this colliding, but there's going to be one issue, and that's if we run around. Notice that I'm just running behind this. I'm not interacting with it. Like, what good is all this? This nonsense to me. So now what we're going to do is coming back over here. We also have to check to see if a player interacts with a star or not. This is super important. This is how when you know two things interact and what's going to happen. So this one, and I will be forthright right now. Yesterday, this is actually where my tutorial stopped. So we are in the weeds together. So we're going to be learning together, which to me is just as much fun. So now we're going to do this physics.add. We're calling this overlap. If these two colliders overlap one another, so not just did they collide, but if they overlap one another, and I'm looking at the player, I'm looking at stars. So these are the two things. Are they overlapping? If I was doing Flappy Bird, I would check to see if my column is overlapping my bird to see if I want him dead. Just keep that in mind. Stars. Collect star. This is going to be a function we haven't built yet. It's coming up next. but that's what it's going to be called. We have null and this. I'm not sure exactly what they do in this context yet. We are going to believe the tutorial. So here we're going to say, I just want to say stars interact with platforms. Player interacts with stars. There we go. And so now we need to go ahead and I'm going to create this function. Let me make sure it's down there past. This should work. So function select star player star disable body. Sure. Let's test this out first and see what's going on. Boom, boom. Our stars are now disappearing. So what's happening here is this. We've now written this, we've called this method, and it takes the player, the stars, these two things, when they overlap, what happens? We have this collect star. And then this collect star here takes the player and the star from here. And what it says is, hey, when this player, when it interacts with the star, what do you want to happen? And we're now saying the star, whatever one it interacted with, whatever one that we clicked on, that's going to be this. We're going to disable the body. This is built in. I'm guessing this is built into every single object. And disable body basically just disables the physics, disables the graphics, and will disable the physics, because physics takes up resources. It's actually one of the most resource intensive things. So I don't want to just turn off the graphics. I actually want to disable the physics. So that's why we're probably disabling body. So this is what's happening. I can now run around and I'm disabling stars. My platformer is looking good. You hear Nintendo calling to me, wanting to get my game. Doing good so far. Let's go ahead, collect star. So far, so good. You've seen we are now playing this. We are now running around collecting our stars. Our stars fall, bounce at a random height. Everything's looking good. But now we need to go ahead and make this count for something. So we are going to start creating a GUI. So let's see now. We're going to make use. There's a text game object, which is great. Usually I might have to build this in like HTML or something, but Phaser is forward looking and they know something. We're going to be doing something. So let's go ahead and we are going to do score text. So we're going to come back over here. I don't need this. This was for a test. I like to keep all my variables grouped together. So I'm going to do var score equals 0, var score text. This is going to be the text object. And so now in our create, so remember, create runs before all of the update stuff. Score text. So score text, our variable, equals this dot add dot text. We are now adding a text object. 16, score equals 0. Font size. So this is probably going to be like the properties of our HTML and CSS. 32 pixels. And then fill. Let's see what happens. Does anything happen so far? Look at that. That's pretty impressive, right? I didn't have to do too much, and we already have our text on the screen. What did we do here? Well, first, I'm guessing this is actually a location. Yep. So 16 by 16 just means it's starting at 16 by 16 down. Score 0. This is static right now. Like it's not actually related to what we touch. And then we have our font size. So if we were to change this, let's try 53, grows bigger. And then our fill. So using this code here, we are going to end up with black. If we wanted to do white, we could do FFF. We'll talk more about color in the future, but just know that you can play around with these numbers and have it change to kind of whatever you want. There we go. Change to green. So we are now at black. Let's move on. So far, so good. Now in our code, where is it? When would we want our score to change, right? Like what group of our code, when do things execute where we want to keep track of our score changing? Well, we know that probably when we hit a star, we're going to want to go ahead and make our score go up. And so now what we're going to do is we're going to come over to our collect star function right here. And beneath that, we're going to do score plus equals 10. So we're adding 10 to our score. And now we're going to update our score text. So score text dot set text. So, and then score plus score. So we're now starting out here. We are starting at 0. This is starting off static. But down here, as we start collecting stars, now we're making this more dynamic. We're increasing our score, and then we're going to be setting the text of the score. So let's test this out. Everything should be looking good. As I run around, 10, 20, perfect. Score is going up. I'm now keeping track. And you'll even notice that because I did uppercase S here and lowercase s here, they're not the same. So we're going to go ahead and change that. Score. Boom. So far, so good. We have a game going essentially, except the fact we don't really have a win-lose criteria. There's no way for me to lose. This thing will just go on forever. Can't even win. So far, this is good. But now we need to add a challenge, a different element to it that's going to possibly defeat us. So now we're going to learn about these bouncing bombs. So again, using the same logic we've been using before. And there's a reason I like to call attention to this, because we really do repeat the same steps over and over again while building this stuff up. We're going to do var bombs, plural. In our create, I'm going to come down here. I'm going to say create bombs. And now we're going to do our bombs equals this dot add, physics dot add. And I'm thinking, I'm not even looking at the code right now, but I'm thinking that it's probably just going to be a group because there should be moving around. That is correct. So we got group. And now we're going to add, it looks as simple as this. We're going to do this dot physics dot add collider, because we know we want our bombs to interact with our platforms. I don't think we've actually added any bombs yet, so we're not going to see anything happen here. Yeah, we're just setting up, we're just rigging it all up for the future. And then this dot physics dot add collider. And then much like, let's see now, collider bomb hits null this. What's interesting is collide means it will stop it. Overlap means it won't stop. So the character will keep moving if they overlap, but with collide, they'll stop. But here, much like in this one, player stars collect null this, we have player bombs. So they're interacting there. Hit bomb is a function we'll be creating in just a little bit. Null is the first thing we would pass in. We're not worried about that. And then this is referring to the bomb that we are hitting. And now we need to come down here and we are going to do this. We're going to do function. We're going to create this hit bomb function right here. We're going to pass in player. We're going to pass in bomb singular because they're only touching one. Hit bomb. This dot physics. So we're referring to the physics of the bomb that's been hit. Pause. We are pausing the physics on it. This might actually be referring to the scene, just so we don't have things jumping around after we've been hit. Player dot set tint. So we are actually going to be able to change the color of the player, which is good. This would be the equivalent of grabbing the game object and changing the material in Unity for anyone following along in that range, in that area. We have player.atoms.play turn. So we want them to turn towards the screen after they've hit. So if they were running, they're now stopped and they're now going to be facing us. It says game over equals true, which is fascinating because I don't know where this game over came from. That could have been me. I'm just going to do game over here and then equal it to false. And I've had to do this before. I've read material that has omitted things before, and I'm just like, all right, I think you want this from me. So I'm just going to make it anyway. Just go with your gut feeling. Otherwise, you can correct it in the future. Don't worry about it. So far, so good. Hit bomb. And now we need to, Jesus. It knows me too well. Now we need to release the bomb. So now we need to actually drop the bombs. So we're going to come back to our collect star. And let's see what it's going to have us do. Let's see what it wants. Because this is game logic. They don't want it to just drop bombs. They want bombs to be a reaction to as you're collecting stars. And so that's where all this game logic comes in. They're going to say if stars.count active. So it will know, see how we disabled the body here? It knows how many stars are still active and inactive. And so we're saying if there are still active stars, stars.children.iterate, same thing as before when we were throwing out our stars and setting the bounds to them. Iterate. Again, we're going to do our anonymous function, child, and here child.enabled enable body. So if we can disable a body, we can enable the body. True child.x, so the location 0, true. I will probably be copy and pasting that in the future. And now this next part, var x equals player.x is less than 400. So if we are within 400 pixels of something, then we go into a ternary. If anyone here doesn't know what a ternary is basically an if statement that just says, if true, assign, like if I said var count equals 0, if true, count equals 5, else count equals 10. All I would be doing is assigning a value, right? So that's what a ternary is. It starts off with your condition. Here it's saying is player X less than 400 away from someone or something. And then I do this question mark, and you can do this in C# and I believe Java also. Phasor.math.between 400, 800. So it's going to assign a value between 400 and 800. Else, if they are not less than 400, then phasor.math.between 0 and 400. So when we pick something up, it's going to assign a value to X. And this X is going to be dependent on if it's less than 400. And then if it is, it's going to assign a value between 400 and 800. Otherwise, if it's greater than 400, it'll be between 0 and 400. And so what does this X represent? This X represents, it looks like a location of this bomb. Because we don't want the bomb to necessarily land directly on us, so it's going to try to place it in a better location. We're going to now do our var bomb equals bombs dot create X, getting this X value, 16, and then calling our bomb asset. This one, the last one we had not used yet from our preload. Bomb.set bounce. We want this thing to be bouncy as heck. We're going to set it to 1. Bomb.set set collect world bound. Same thing with our player. It will not fall out of bounds now. We're setting this to true. Bomb.set velocity. How fast do we want to go? We're not even doing it X or Y. We're saying the velocity for everything. So velocity phasor. Again, we're just using this math library between -200, 200, and then 20. So I believe this is coming in from the sides at -200 to 200 speed. And then this is going to be the Y value, so what's dropping at. And then, so without even looking, the bomb should fly in every time I collect a star, and it's going to be trying to hit me, and I have to evade them. And if I don't, then game over will be true. So let's find out. I just did a lot of code without knowing if it's going to work. Don't do that. Bomb, that's looking good. I see bombs. This is looking good. What happens if I hit? There we go. Notice that it did not go through. It collided with it. It played the turn animation, so I'm facing forward. It changed the color of my skin to this FF0000. This is RGB, so FF represents R, and this is actually the most vibrant red because 0 represents the minimum value, F represents the max value. So that's what this represents. And then somewhere game over triggered. This also stopped everything from moving because our physics is now paused. If I were to turn this off and do the same thing, still keeps going, right? Our physics are not paused. I can actually push these bombs around, which is a lot of fun. That's because they're colliding, not overlapping. So that's what's happening here with our pause. And now there's probably just the last thing. What happens when we do game over? It's interesting. They don't have, they just have a value that says game over. But they don't have anything that actually represents game over. So we're just going to do this. Let's take a look at our code. This was the set text. And game over. There we go. Playing around. Game over. Perfect. So as you can see here, and I will go ahead and push this up online because I'm curious. They were adamant that I have to have a WAMP server running in order to get this to run, but I actually got it to run through live server here. So I'm going to be pushing this up to GitHub to see if this will run without needing a server running in the background. And I will post this for everyone to be able to play online. But really follow this tutorial. As you saw, it doesn't take too much time. And it does a great job of breaking down all these individual components. You now have a fully working platformer game. It's easy to get into. Just use Phaser, play around with it, have fun. And this will also deploy mobily, which is nice. So you should be able to play it on your phone too. So, all right. Does anyone have any questions about Phaser or even game development? If you have any questions, because again, I can talk on that for hours, but might have to save that for another day. But yes, any questions?
I think I'm good.
I think you're good. You know, but you know, I would not be surprised at all. Like a lot of these things like have foundations on this where you can see it's just like once the physics engine is down, right? Like, and for me, that's like the most complex thing. There are brilliant people writing physics engines. And Benner just brought up how this must be how they made Bubble Trouble. Yeah, like take a look at this, throw on some physics here, and then have a character that's running around, have them aim up. I love these kinds of games. I remember these from when I was a kid. And then you just have an object when you face up, a single object, a new instance of an object goes up. And if the two collide, then it breaks up into smaller portions and you can do it size divided by 2. Those both have physics start bouncing around until they get the smallest value, pop them, boom, start adding the score, otherwise blah, blah, blah. Could absolutely do this. In fact, if you wanted to have fun, use Phaser and recreate Bubble Trouble in a weekend. And that would be really cool to show off. In fact, that makes me want to look into doing multiplayer on Phaser because I believe they probably have that going on too. That'll be a larger conversation for the future. But yes, probably. Just to answer your question, yes, probably. All right then. Well, if no one else has any questions, it was a pleasure to show off Phaser to you. I'll probably be doing more tutorials on this in the future because it's a ton of fun and this is right up my wheelhouse. So if you have any questions, feel free to shoot them out to me. I'll be more than happy to address them. And then I look forward to talking with you all in the future. I'll go ahead and stop recording right now. Y'all take care.